I need my administrative stuff, and that's from the school. This is a school laptop, so I can't.
Well, that's fine. You don't have
Yeah,
to download stuff.
that's all.
This is the way it's going to work. Let me just show you.
All right.
Whatever I write, you see.
Yes, I do. Yeah.
Okay. See that number 7?
Yeah.
All right. So go ahead and verbalize the problem. I'll write it down, and then we'll tackle it.
Okay. Well. Okay. I'll just go to the thing. I thought they would have sent something to you. That's my fault. Okay.
It's actually almost easier to verbalize.
Yeah. No, I know.
If you're looking at a graph and they want you to come up with the equation of that function, different story. Then I need to see a picture of that graph. But if it's just solving equations or something, go ahead and give me the equation and we'll solve it.
Okay. Just give me a sec. I need to pull it up because.
Oh, it's online?
Yeah, everything is online. So.
Okay. The other alternative is you could send me to that website. I would pull it up on my screen.
I can't. It's only accessible to students.
It's better to verbalize it, actually, because something happens when you start verbalizing it. You learn it a little better.
Yeah, you're right. While I'm waiting to do this, I had a quick question actually, because me and my dad were doing a problem, and it said the sixth root of 0 does not exist. Is that I don't know how that works.
The sixth root of 0.
Yeah.
Okay. Normally, to find the nth root of something, you're going to use de Moivre's theorem, right? You familiar with de Moivre's theorem?
No, unfortunately, I'm not.
Well, unless they have given you de Moivre's theorem, then you can't find the sixth root of numbers. The only way I know to do it is using de Moivre's theorem, which is to translate that number into a trig polar function, and then you can apply de Moivre's theorem to it to find the sixth root or the eighth root or something like that.
Well, it's just 0. I don't know. It's like a theory question.
You're not going to have the sixth root of 0 because I don't know of any two numbers that multiply together that give you 0 unless one of them is 0.
0, right? Okay, so I would think the answer would be 0 to that because the square root of 0 would be 0, right?
Right. However, you run into problems if you are interested in the sixth root of 1. You might think there's only two answers, -1 and 1. But in actuality, there's a bunch of answers. There's 4 more, and they're complex numbers.
Oh. Okay, yeah, right.
You might have 1, I don't know what the sixth roots of 1 are, but one of them could easily be like 1 plus I.
Right.
And then if you multiply that by itself 6 times, you get the number 1. That's basically what the sixth root means. So I can't imagine the sixth root of 0 being anything other than 0.
Right, but it says the answer does not exist, so I was confused about that.
Yeah, I'm a little confused by that also, but...
All right, it's okay. I'll ask him. Oh, no, it doesn't matter. Okay. It's not going to show up on the test, right? Okay, so I opened up my stuff.
Okay.
So right here, what I'm confused about here is piecewise functions, right? And I understand the basic concept of it, behind it. Like, I understand everything.
Okay.
But, like, when it has something to do with one-sided limits, I get confused. I don't know what the answer is.
Go ahead and give me the piecewise function.
All right. It's f of x is equal to the thing. I don't know how to. Can I draw on this, or how does this work?
No.
I
can actually. I have the ability to make you the presenter, but that rarely helps. It's much better if you can verbalize it, and I'll write.
Yeah. I don't know what that's called, but yeah, that.
I don't either. to be honest, but I know what you're talking about.
Okay, perfect. Okay. On the top, it says x plus 1 if x is greater than 0. And on the bottom, it says minus x minus 1 if x is less than or equal to 0.
Okay, so first of all, let's graph that.
Okay, yeah, that could help.
And
Yeah.
the way you graph these is you always start in the upper right. Okay, there are two domains we need to care about. There's everything to the right of this, and there's everything to the left of it.
Right.
Okay?
Mm-hmm.
And that's the way to think about piecewise functions, is divide it up vertically, like I've done.
Okay. Could we just like plug in numbers into this?
Well,
and then
all we have to do now is plot. What does x plus 1 look like? What's the y-intercept going to be?
0, right? What? 1. Oh, 1, right. 1, 1, 1.
It's going to go through 1. What's the slope?
Okay, 1 over 1. So rise or run 1 over 1.
So the rise is 1, the run is 1. So if I were to graph that top function, I would get that. And since it's only when it's greater than 0, we have an open circle on that end.
Mm-hmm.
Now we plot the bottom function. Well, that goes through this point down here, minus 1.
Yeah.
And it's a closed circle. And what's its slope?
It's going to look like, it's going to go minus 1 is the run. That means it's going to go down 1.
It's a minus 1 slope.
Yeah. So it's just
That's the graph of this piecewise function.
Oh. Oh, right.
Simple as that. In other words, just break it up by domain and then graph each function in that spot. In other words, whenever I'm to the right of the y-axis, I'm graphing x plus 1. Whenever I'm to the left of the y-axis, I'm graphing minus x minus 1.
Okay, wait. Quick question though. When it says equal, greater than or equal to, or less than or equal to, does that have any?
That makes it a closed circle.
It's closer. Oh, right. Okay, so
that's why this is an open one.
That's a hole, right? Is that a hole? Okay.
So what's the function equal to at 0?
What's equal to -1, right?
Yeah. Yeah.
Okay.
What's the function equal to? Okay, so now give me the limit question.
Yeah, okay. So limit is, the A part says limit x tending to 0 minus. So from the left, what is f of x?
Like that, right?
Yeah.
Okay. So if we're approaching 0 from the left,
that would be -1, correct?
We hop on board the function, put your pen on that, and start going towards 0 is the best way to think about it. What are we headed to?
-1.
Okay, so that limit is -1. What's the second question?
The second question is...
Hold on, I didn't write that correctly. There you go, -1.
Oh, okay, yeah, -1. The second question is from the right.
Okay, hop on board the function from the right.
Well, is it technically D and E? If that's the question I had.
No, it isn't. It is headed towards something. What number is it headed to?
Okay, 1.
Okay. Now, there's a rule about limits. If I want to know the limit as x approaches 0, it only exists if the limit from the left is the same as the limit from the right.
Okay.
In this case, they're not. One of them is -1, one of them is +1.
So yeah,
the limit as x approaches 0
is D and E.
does not exist.
Right.
They
If it
only
matches, then
exist if
it's
they're the
continuous,
same.
right?
They have
This
to
is
be.
discontinuous, right?
I'm sorry, what?
This graph is discontinuous. Is that what it is?
Yes.
In
If you
Piecewise?
have to
Yeah, that's
lift your pencil up off the paper to draw it, it's discontinuous. That's the
okay.
layman's definition of continuity. There's a
Right.
math definition of continuity, and it has to do with, first of all, the limit from the left has to be the same as the limit from the right, and the limit at that number has to equal that.
All right.
So,
Perfect.
okay? But the
Mm-hmm.
best way to think about continuity is if you have to pick up your pencil to draw the graph, then it's discontinuous.
Okay. Fair enough. Okay. Well, this was sort of simple compared to the next problem, which I just saw. Okay. So this is different. Okay. So this says f of x is equal to the thing.
Mm-hmm.
Uh, and on the top, there are three ones for this
Okay.
one. Three. Okay. So there's on the top it says x squared if x is greater than 2. Minus 7 if x is equal to 2. And 6 minus x if x is less than 2.
Okay. Notice that we're covering the entire domain of all real numbers. And
Yeah.
just to emphasize what I'm talking about here.
Is this going to be a parabolic function or no?
Oh,
It can't be, right?
I don't know. There's two.
Okay.
We've got three areas and put them in different colors. Got this area. Got this area. And then we've got the blue line when it's equal to 2. And
Okay.
unfortunately, I shouldn't do that because it's hard for me to erase it now. But it's so important in understanding piecewise functions that you look at it like that. That's always the first thing I stress with students is make sure that you're looking at it as domain differences.
Mm-hmm. Okay.
Okay. Now,
Yeah.
let's try to graph it. When it's greater than 2, it's equal to what?
When it's greater than 2 is equal to x squared.
Okay. Now, there's a couple of ways to do this. I'm going to do it the way I used to do it, which is to graph the function and then erase everything that's to the left of 2. In
Yeah,
other words,
right.
the function I
It never.
just graphed is x squared, correct?
Oh, yeah.
But it's not x squared when we're to the left
Okay.
of 2. It's only x
Mhm.
squared when starting
Greater
right
than.
there.
Right.
Okay. And now when x is equal to 2, the function is minus 7, right?
Mm-hmm.
Hold on. So down here at minus 7, that's what it's equal to when it's 2. With me?
Yeah.
And then the third function is everywhere to the left of 2. What's the slope?
Mm-hmm.
What's the slope on the bottom part of that function?
Well, it starts at the y-intercept is at 6, correct?
Right?
And then it's minus 1. The
Minus
slope is 1.
1. So that function looks something like that. Okay?
Mm-hmm.
And it's open there. And this one's open there because it's a greater than or a less than.
Right.
But the entire piecewise function includes that point right there. So the function is defined for all real numbers, correct?
Mm-hmm.
It's defined less than 2, it's defined at 2, and it's defined to the right of 2.
Okay.
So now give me your limit questions.
All right. The limit questions are, okay, 2 minus, 2 plus, and 2. So limit x tending to 2 minus from the left. Okay, so.
Okay. What's that equal to?
Okay, so 2 minus 1, it's less than 6 minus x, right?
Yeah.
Are we using that one for that one?
Yeah. In other words, where does this dot right there occur on the y-axis?
4.
Yeah.
4.
That's at 4.
Yeah, okay.
So what is that limit?
4.
Yeah. It's headed towards 4.
Right, yeah.
Now, what is the limit of f of x as we approach 2 from the right?
That's going to be 4 as well, right?
Yeah.
Okay.
Not the way I've drawn it, but that's the way it should be.
Oh, okay, then limit x tending to 2 would also be 4.
Well, no. What is the
Continuous?
limit
No.
of this function
No,
when
ah,
x
right.
equals 2 is 7?
Minus 7. Oh, wait, -7, yeah.
Right. So here's where you get into the mathematical definition of continuity.
Right,
There's
okay.
3 things that have to be true for a function to be continuous at a particular point. The only point in question here is when x is at 2, right? Otherwise, the function is continuous. The 3 things that have to be true is the limit from the left has to equal the limit from the right, which is true in this case. Let me redraw it. Let me redraw it here to be a little more accurate. It's the half. It's the other part of the parabola.
Ah, right.
Okay, so for that to be continuous, the limit from the left has to be 4, the limit from the right has to be 4, and f of 2 has to be 4. In other words, this bottom is not really a limit question. It's what is f of 2? So if f of 2 was equal to 4, we would have a continuous function. It's not. It's equal to 7.
-7, yeah.
Therefore, mathematically, this is not continuous at the point x equal 2.
Okay, so
We can see
basic
that.
continuity.
Look at it. I can't draw this function without picking up my pencil.
Right. Yeah, you're right. Okay.
If at x, when x is equal to 2, if it was equal to 4, then it would be continuous. In other words, if this dot that I have down here at -7 was at 4, if I turn that -7 into a 4, this -7 right here, if I make that 4, we would have a continuous function. It would still be piecewise. The only way you'd be able to define it would be piecewise, but it would be continuous because the limits from both sides equal each other and are equal to what the function is at that point.
Okay. So wait, so the continuity rules don't apply to piecewise functions, basically, like the ones that we
They
learned
actually
before.
do. No, they do. Is all I would need to do is change this slightly. Make that a 4. Now we have a continuous function because this point that I've drawn down at 7 is right here.
Yeah, but I mean, like, if it's given as -7, then we. But like the rest not.
7, it's not continuous. But I can still have a piecewise function that is continuous. That's what this is that's continuous.
Okay, let's say we have a different, like a non-piecewise function,
Okay.
right? And it's both the other limits tending to what like 2 are both 4, they match.
Let me draw
Normally,
here. I
right?
think
Like,
this is what you're talking about.
oh, yeah, that might be. Oh, okay.
Okay. That's
Right,
not
right, right.
continuous because
That's
there's
not
a
continuous.
hole in it. If you have a hole
Ah,
in your function, it's not continuous. I can't draw this without picking my pencil up off the table.
okay.
But take away the dots,
And it's continuous. Okay.
and it's continuous.
Okay, I thought I've been under the impression that if you have even a hole and but then you have a dot at the top, like a full dot, that you could it
That's
could
not
be
that's not continuous. No. It
right.
really is
Okay,
true that if you have to pick your pencil up to draw it, it's not continuous.
I see.
I mean, it's
Okay,
not very mathematical explanation. The mathematical explanation has to do with limits from the left, the right, and the value at that particular point. But
Mhm.
easier way to think about it is if I got to I didn't have to pick my pencil up to draw this graph.
Okay, yeah, you're right. Okay, well, we can move on from piecewise functions because there's about 2 more concepts I need to learn.
Okay.
And real quick, before I go into those 2 concepts, I just want to make sure I understand this,
Okay.
right? And it's another limit question.
Okay.
You can write it down as limit x tending to -2. Okay. And then it says x plus 2 on the top, numerator, and x squared minus 4 on the bottom, right? And
Hold on.
okay, wait,
Hold
I'll let you. Yeah.
on. X plus 2 on the top.
Yeah, x plus 2 on the top and x squared minus 4 on the bottom, right? I just want to make sure I understand this concept. I'd have to factor the bottom, right, to make it x plus 2
Correct.
into x minus
The
2.
very first thing you would do would be to substitute.
Yeah, but that won't work
Well, it
because
gives you 0 over 0.
which is D and E, and you don't want it. You don't want
Well, it's not D
that.
and E. No, it isn't. It isn't D and E. 0 over 0 is not D and E.
Oh,
But
uh,
0 over 0 is undefined. We don't know what it is. But there are
yeah,
some
undefined.
things we can do to find out what it is. One of
Yeah,
them is factoring.
yeah.
So,
There's factoring, conjugate, and then there's the other one.
well, what happens if we factor this is we get this.
X plus 2 into x minus 2. And you cross out the
Now
top.
you can cross off that. And
Yeah,
so it's really 1 over x minus 2. And now
which
what's the limit of this as x
minus 1
minus
over
2?
4.
What is it?
Minus 1 over 4, right?
Yeah, minus 1/4. So that's what the
Yeah.
limit is. That's not 0, and it's not undefined. That limit is minus 1/4.
Okay. That's yeah. Okay, good. Okay, I want to make sure I understood that.
The one thing to keep in mind is just because I crossed off the x plus 2 with the x plus 2, it does not
Mhm.
relieve the domain restriction. In other words, x can still not be minus, or it still can't be minus 2. If I were to graph this, let's see, I got a horizontal asymptote there, I got a vertical asymptote there. So it's going to look something like this, hyperbolic. And the fact that x cannot be equal to minus 2 puts a hole right there.
Mhm.
Now, if I look at just the final function, 1 over x minus 2, I don't see that restriction. The only restriction I see is x can't be 2. But the fact of the matter is just because I canceled out those 2 factors does not mean that I can now be minus 2. I can't. So it leaves what is called a hole. And
Oh,
this is the proper graph of the function you gave me, this function over here.
Huh. Okay.
Okay. Now, if we wanted to know what the limit is as we approach minus 2, well, that's minus 1/4 from either direction.
I see.
In other words, if I'm approaching minus 2 from the left, I'm getting on the curve, I'm approaching this point right there. If I'm approaching it from the right, I'm hopping on the curve right there. I'm approaching the same point, minus 1/4.
Okay.
Okay?
Mm-hmm. Well, okay. That's good. Okay. For the first concept I want to learn real quick is I'll give another problem. It's complex numbers.
Okay.
Now that's what we're going into, and okay. So I understand like these first. Okay, you can't see it, but all right.
Can you verbalize?
Yeah, I'll verbalize. Okay. So f of x is equal to 2x to the power 4 minus x to the power 3 plus 49x squared minus 25x and minus 25. Okay, so basically, one of the zeros is given, which is 5i, which is basically, so now I know that there are two zeros already given, x plus 5i and x minus 5i, right?
Yes. Imaginary solutions always come in pairs.
That's for, yeah.
Okay.
That's,
so
but now
if
I need to find the other two zeros, right?
Okay. If I divide this quartic, the original function, as a quartic function, if I divide it by one of the zeros, I end up with a cubic. And then if I divide it by the other zero, I end up with a quadratic.
Oh.
So that's how you do it. So let's do it. You're familiar with synthetic division?
Yeah. But wait, for synthetic division with 5i, how can I?
Well, I'll show you.
Yeah.
Actually works just the same.
Okay. 2 minus 1, 49, that's 5, that's 5, okay. I'll do it here, so. Bring down 2, okay, so you get 10i now, right?
Mm-hmm. Now, it's harder, but it works the same. In other words, that's minus 1 plus 10i.
I see,
Still
okay.
add. Okay. Now,
I'm guessing they're going to cancel out later, right?
What's that?
I'm guessing the i's are going to cancel out later at some point.
After the second division. In other words, the first division is going to leave you with a lot of i's in your cubic. But then when you divide by minus 5i, all the i's will cancel out and you'll be left with a quadratic.
Okay.
You don't really care what this answer is. After going through all of the arithmetic, you'll get an answer that has imaginary coefficients for your cubic. Well, you don't care what that is. They don't even ask about that. Do the process again using minus 5i, and you will end up with a quadratic. I don't know what it is. Let's say that it's a 2 here, a minus 3 there, and a 10 there. That means x squared minus 3x plus 10.
Yeah, so and then you can get the other two zeros.
Yeah, so here, let me write it in blue. If I were to write the four factors of this, it would be x minus 5i is one of them. X plus 5i is another one. Excuse me. And then x squared minus 3x plus 10. So if I were to factor this, I would have those two zeros, and then I would have this quadratic. And you know how to find the zeros of a quadratic. You can use the quadratic formula if it doesn't factor easily.
Actually, yeah, this specific one doesn't have two exact zeros, correct?
This specific one has, hopefully...
I mean, x squared minus 3x plus 10 won't have two factors.
Yeah, it'll have two, you're right, they're imaginary also. So you have two possible solutions. You could end up with 4 imaginary factors, or you could end up with the 2 imaginary factors they've given you plus 2 real factors.
Right.
Here, let's make this minus 10 instead of plus 10. And now...
Yeah, if you make it minus 10, yeah, you get like a...
x minus 5 times x plus 2.
X plus.
And you have 5 and minus 2 as the other two zeros. So the goal here is to always bring it down to a quadratic. Do whatever you have to get it down to a quadratic.
Right, yeah. Wait, real quick though, if I had to multiply, like where we left off, x minus 5i into 5i.
Right.
Oh, no, sorry, no, that's wrong, sorry.
I'll do one more step for you to show you.
It'd be 45i, am I right with that? Like in the...
Here's what I'm going to put, just a second. So 5i times minus 1 is minus 5i. And 5i times 10i is 50i squared, which is minus 50.
Oh, minus 50i squared. Oh, minus 50i squared is minus 50, right? Right.
Or 50i squared is minus 50. I squared is minus 1.
Yeah, I forgot about that.
What I had was positive 50i squared.
Right, I forgot about that rule.
Okay. So now I'm going to add 49 to this number, and I'm going to get minus 5i minus 1. Now I'm going to do the whole same thing again to produce a number there, to get a number there, do the same thing. And this has to be 0, or else they were lying to you when they said they were factors. In other words, there's something called the zero remainder theorem.
Yeah, if you don't have a 0, then it's not a factor.
Yeah, if you don't have a 0 in that last spot, then that's not a factor. It has to be 0 if 5i and minus 5i are factors.
Yeah.
And if you discover it not to be 0, then it's not a factor. It's one way you test whether something is a factor or not.
Okay.
So, whatever I get, let's say I get something like this. I'm just going to make up some numbers here. Let's say 6x plus 2 that goes there. Now you do the same thing, only you use the other 0 minus 5i.
Wait, what would I write for the next minus 5i? Like, what would I write for the numbers, like, on the top?
What you're looking at. The answer where my red arrow is, those are your numbers.
Oh. Those are the same numbers I put up. Okay, that's perfect.
That's the coefficient of x cubed. That's the coefficient of x squared. That's the coefficient of x.
Perfect, okay.
Okay, and then do the whole thing again, and you'll end up with a quadratic down there.
Okay.
Once you get it down to a quadratic, you're kind of done. Well, you're not done. You still have to factor the quadratic. But now you have 4 answers. It's easy to handle quadratics. What is tough is cubics, quartics, quintics. It's very difficult to factor, even a cubic. I don't know, have you gotten into factoring cubics yet?
Yeah, honestly, I kind of find that easy. Okay, I learned about this thing I learned on YouTube, actually. But okay, I can give an example.
Okay,
like
erase everything.
Yeah.
Go
It
ahead.
seems right. But it has to be a specific type of cubic. That's why it doesn't work all the time, you know?
Oh, you're
So,
talking about grouping.
yeah, grouping. Yeah,
Yeah,
grouping. That's
no,
it.
that works on about 1% of cubics.
Yeah, it works on the, yeah.
You have to be very precise in making up a cubic. Here, I'll tell you what's needed. I'll go ahead and give you one. Sorry about the extra scribbles here. I'm not sure what happens there. Kind of think my hand gets sweaty or something.
No, that's
If the ratio of that coefficient to that coefficient is the same as the ratio of that coefficient to that number, you can use grouping.
right. Yeah,
That's
exactly.
what has to be true. Those ratios have to be the same. If I change that to a 7, I cannot use grouping.
Yeah, yeah. There's another example right here. It's like x cubed minus 7x cubed minus x plus 87. Like you can't. There's no way I can
Let me
use
write
grouping.
that out because there is a bit of a problem that you have to be wary of. Go ahead and give me the one you just read.
Okay. X cubed minus 7x squared. Minus x plus 87.
You can't do that by grouping.
Yeah. Yeah. I tried that.
Are you familiar with the rational factor theorem?
No.
That's the way you solve it. If you can't solve it by grouping, the only way to solve it is the rational factor theorem. I don't know.
One of the zeros is given already, by the way.
That makes a big difference. What's the 1 0?
Yeah. It's 5 plus 2i.
So you have 2 zeros then.
Yeah, 5 plus 2i and 5 minus 2i.
Imaginary zeros always come in pairs, never alone.
Right. Yeah, there's only one factor. Sorry. There's only one factor left.
So I'm going to divide this cubic by 5 plus 2i. I'm going to take my answer and divide it by 5 minus 2i. And I'm going to be left with a linear factor that will give me one real answer.
Mm-hmm. Wait, quick question. Could you do 5 plus 2i into 5 minus 2i, see what that gets you, and then use that by chance?
Divide the factors into each other. If I told you that the 3 factors of this are 4, 6, and 9. Well, never at any point in time do I divide 4 into 6 or 6 into 4 or anything.
No, I'm saying like you'd have x minus 4 into x minus 6, and whatever that gives you, you can use long division on this to find 9, right? Couldn't you?
Exactly. Or you could use synthetic division also. Synthetic division is a lot easier when you don't have an imaginary number in the box.
Yeah. No, I'm saying, does that same rule apply with imaginary numbers? Like, could you do the 5 plus 2?
Yes.
5 plus 2.
If you had, if they just gave you 1 0, let's say they said that the 0 is not an imaginary number, but it's 3. Okay. Let's say they said one of the zeros of this cubic is 3. So all I got to do is synthetically divide the cubic by 3, and I'm going to be left with a quadratic, which I can then handle. Whether you have to factor it or use the quadratic formula, you can handle it. In other words, there's no such thing as a cubic formula. We have a quadratic formula for handling quadratics, but there's no such thing as a cubic formula. Too bad, because it would make these a whole lot easier.
Yeah, it would.
Most people come upon the quadratic formula and they hate it. It's too complicated, but at least it's there to use. When you have cubics, there's nothing there. You got to do it the real hard way.
Wait, quadratic as in like the minus b plus or minus, that one?
Yeah.
Oh, okay.
Okay. Let me just give you a quick primer on this because you're going to be given this shortly. If a cubic has a rational 0, its numerator is a factor of the constant, 87, and its denominator has to be a factor of the coefficient of the x cubed term. So the possibilities here are 1 and 87. No, that has other factors, doesn't it? Yeah, that has a factor of 29 and 3.
Yeah, it probably does. I don't know.
And the bottom is 1. And whenever you're doing it this way, it's always plus or minus.
Oh, P and Q. Yeah, yeah. No, I know this one. Yeah,
Okay.
yeah. Right.
So I don't need the denominator anymore since it can only be plus or minus 1. So if there is a rational factor to this cubic, it has to be plus or minus 1, plus or minus 87, plus or minus 3, or plus or minus 29.
Right.
And the way you handle it from here is you try each one of them, starting from the bottom, starting from the easiest, plus or minus 1.
Yeah, plus or minus.
In other words, you could do 7 processes here, and you finally get to negative 87, and that's a 0. But in other words, I might have to do 8 tests, right?
That trial and error takes too long.
I got to test plus or minus 1. I got to test plus or minus 3. I got to test plus or minus 29. One of them is going to produce that 0 in the last spot, and that will be a factor.
I'm guessing it's going to be 3.
Well, I made these numbers up, so. Oh no, you gave me this function. Yeah.
Right, yeah. No.
Okay, well let's find out if 3 is or not.
3 or minus 2, one of those two. I don't know.
All right, let's find out. Right. Pretty easy to find out.
Let's see if the remainder is 0. Yeah.
Yeah.
1, 3.
Nope.
No. What about minus 3?
Okay, let's try minus 3.
Yeah, this probably, yeah, this is it.
Oh, that's 29. Yeah. I added it wrong. That's 29. That's minus 87. That's 0.
Yeah.
So you're right. Minus 3 is one of the factors, and the other factor. So x plus 3 is one factor, right? The other factor is that quadratic. X squared minus 10x minus 29, plus 29.
Yeah, plus 29. Yeah.
And now you can use the quadratic formula to factor that and get your other 2 factors.
The other 2 factors are going to be x plus 5i and x minus, or no, 5 plus 2i. Okay. 5 plus 2i. Yeah, right? They're already given.
I would have to use the quadratic formula. I don't know that by looking at it.
Oh, no, they'll give you 1, 0 on the test.
Okay.
Yeah, for the future, yeah.
So the answer to your first problem was minus 3 is the third 0.
Yeah.
Okay.
Quickly, do we have enough time for one more thing?
Sure.
Yeah? Okay.
No, what are we going to do, an hour here? I just go ahead and bill you for whatever time we use.
Oh, okay. I just have one more.
I'll bill for an hour and 10 minutes if it's an hour and 20, so it doesn't really matter when we stop.
Yeah. Okay, fine. I just wanted to know if you're on your time.
I've got a few minutes. I don't have like a half hour, but I've got some.
Yeah. Okay, that's fine with me. I just need
one more problem. Sure.
Okay. So rational functions. Okay. Okay. Let's go into this. Okay. All right. So this is it. Is about finding the domain. Okay. I don't know how to. Can I send this to you? Can I just like copy paste this?
Can you verbalize it?
Okay, well, it's from a graph, and I have to find the domain, vertical asymptote, all that stuff.
Okay.
So
That's going to be hard. You don't have the function?
no, I don't have the
Okay,
function.
let me tell
Okay.
you where to send it. I don't know how long it'll take, but mainly because where you're located. Send it.
No, that's
Send
fine.
it to this. Let me give
That
you
way.
the email address to send it to, and then I'll bring it up on the screen and we can talk about it. Or I
Okay.
could just draw any old function and we can talk about domain and range from what I draw.
Well, no, it's a piecewise function. It's fine. It's fine. It is going to take a maximum of like 1 minute, 2 minutes.
Okay.
What's the
Send
email
it to
address?
here. David Cowan,
How do you spell Cowan?
C-O-W-A. I'm writing it on my screen.
Oh, okay. I'm on my email. Okay, it's COWAN. Okay.
At gmail.com. David Cowan 1949 at gmail.com.
All right. All right, there you go. I sent it to you.
Okay. Does it say? There we go.
Yeah, there it is.
Okay. So when you're trying to figure out domain, you want your eyes to go left and right.
Okay.
Don't let them go up and down. Let them go left and right. Domain is all about what x can be. Starting
Okay.
from negative infinity.
X can be
Go ahead.
all real numbers except for, well, no, actually it can't be -1, right?
Okay, that's correct.
Yeah, that's it. Never mind. All real numbers
It
except for
also
-1.
can't be +1. Look at the hole at +1.
Oh, there's a hole. Yeah, sorry, I didn't see that. My bad. Yeah.
So in interval notation, it would
Yeah,
be
you write
negative
the thing, right?
infinity to -1, parentheses, in union with
Union.
-1
Yeah.
to 1, parentheses, in union with 1 to infinity, which is the same thing as saying all real numbers except -1 or 1.
Yeah. And 1. Okay.
Okay. So do they want it? Do they always want it in interval notation?
No, no. I'm just gonna write the R, the
Yeah.
weird
Double
R.
R. Yeah. Yeah. You can
Yeah,
write
that thing.
double R except x cannot
Except
be
-1 and
equal
1.
to
Yeah.
-1 or x cannot be equal to 1.
Yeah.
It's the same
That's it.
thing. That's legit. You can state it like that. About
Yeah.
vertical asymptotes.
Vertical asymptote. Okay, so that's just what's it called? Uh, -1, right? X equals -1.
It's the equation of a line. And so it has to be written as an equation. It's x equal -1 is the vertical asymptote.
Okay. Yeah. X equals -1.
And let me fill these out as we're going here. I can write on this thing. So I'm not going to fill out that whole domain, but the vertical asymptote is that. It's the equation of a line. It's that vertical line you see.
Yeah.
What's the horizontal asymptote?
Y equals 2.
What's the x-intercept?
Is it -2?
Yeah.
This one -2, 0, right? -2, comma 0.
Okay, yeah. If they want it as an x-y coordinate, yeah, -2, 0. What's the y-intercept?
Right, 4. 0, comma 4.
0, 4. And where's the hole?
See, that's what I'm confused about. Do I write do I write 1, comma 3, or do I write 3?
No, 1, 3 is the hole.
1, comma 3.
Mm-hmm.
Oh, okay.
Yeah, they want an x and y coordinate for the last three questions here. The x-intercept, y-intercept, and wholes. They want the answer as an x and y coordinate, I'm guessing. With other students, that's usually what they're looking for.
Yeah. Okay. Well, that's pretty much all my questions.
Okay.
That's it. Just want to clear some concepts.
Yeah.
Okay.
Ayush? That's how you pronounce your name? Ayush?
Yeah. Ayush. Ayush. Yeah, that's right.
Okay. So what are you doing in Qatar?
Well, my dad just works as an electrical engineer, so we move a lot,
Oh.
and yeah, it's petroleum, oil and gas. That's what.
I used to be a geophysicist. I know all about it.
Oh, that's oh wow. Okay.
I worked for Amoco Oil for 4 years, many years ago.
Wait, Aramco?
No, Amoco. It's no longer. It was bought out by I don't know who, but it used to be one of the major oil companies in the United States, based out of Denver.
Denver. Yeah, I love that.
I don't know who bought them out, whether Chevron bought them or whatever, but the Amoco name disappeared. Different than Aramco. I'm familiar with Aramco.
Yeah, Aramco is based in Saudi Arabia.
Your dad's working for is Aramco?
No. Actually, yeah, Qatar and Saudi Arabia we're fighting right now. So.
Oh, I didn't know that. Wow.
Yeah.
So Qatar, are you close to Yemen?
Yeah, we're all.
I knew that Saudi Arabia and Yemen were fighting, but Qatar is on.
We're actually in the middle of a blockade by every other
oh my God.
Arabian country except for Egypt, I believe. No, okay, never, not Egypt. Sorry, Lebanon. I don't know. It's just actually most of the Arab countries hate us right now.
Oh, that sounds like a tough place to be right now.
Yeah, I know. Yeah. We didn't even do anything.
Well,
no, that's fine.
Good luck.
Yeah, thank you. Appreciate it. I'll tell my mom to contact you if you ever need to.
Sounds good. You have my email address now. So further communications are actually going to be easier if she just communicates directly to that email address. And she can set up appointments. We'll still go through Wiseant for billing purposes. But in terms of communication, I'm not sure how much delay it is if you send a message through Wiseant. I don't always get it immediately, whereas if you send an email, I get it pretty quick. You saw it only took about 10 seconds for me to get that email.
Yeah.
So if she wants to set up another session, have her email me, and I actually have an online scheduler that I can direct her to, and shows my complete availability and lets her make an appointment.
All right, perfect. That's how we'll set it up.
So, all right. Yeah. In fact, you might want my website, digitalmathtutor.com.
Digital math, okay.
Digital Math Tutor. Yeah, you should visit that website. As I said, I'm not trying to bypass Wiseant. I would never do that. But my website has that scheduling on there, and she can actually schedule sessions herself without talking to me or anything.
Well, that's easier for us. That's good.
Yeah, for sure.
All right. Well, thank you so much, sir, for your time.
The way you close out of this is just to click on the X. Actually, you're on their website, so I guess all you need to do is close out their website. And you're off.
Yeah, I just need to close the tab. Once I close the tab on the video. Yeah. All right. Have a nice day, sir.
You too, Ayush. I will talk to you again, hopefully. Bye-bye.